normal distribution. So first of all, you can see normal distribution. You will always see a bell-shaped graph. Okay? Bell-shaped graph. So where the maximum point is the mean, you see x equal to mu. Mu means mean. Okay, so what else do we need to know? You can see here, number one, a random variable x which has a normal distribution is a continuous random variable. So what is important here is you have to know that normal distribution is a continuous random variable. So what is continuous again? Continuous is something that you get from measuring. And the other thing is they can take the values in an interval. They can take all values in an interval. Okay, so include decimal number. So where discrete, right? You know they can take exact number. Normally it's like they can only take 1, 2, 3, 4. That is discrete. But continuous, they can take decimal, integer. Okay, so they can take all the values in the interval. Example, let's say height. You know, height can take all values in the interval 163.5 cm. Okay, can take decimal. 164 can take exact value. Or weight. So all these you get it from measuring. So they are under continuous. So for example, why we have this kind of graph for normal distribution? You just imagine, let's say in your class, so we want to find out the height of the students. Okay, let's say some of them are maybe one or two of them are very short, or maybe two of them are very tall, and then most of them are just around 160 cm, for example. So like the average is around 160 cm. Okay, example. So that's why the graph is higher up here, because many people have this height. So very little people are tall. Okay, like 180 cm is like a bit rare, for example. So that's why it's low here. And let's say 140 cm is kind of rare also, so that's why it's kind of low over here. So most of them have height around 160, 150, or 160 something, so that's why here is kind of high. Okay, so it's this idea. Now we see more information on normal distribution. So how we write normal distribution, we write in this way. A normal distribution, we write x first to represent the variable of normal distribution, followed by a wave, followed by n, bracket, followed by this mu is mean, and followed by this is sigma square. Sigma square is variance. Sigma alone is standard deviation, so sigma square is variance. So this is how we present a normal distributions. So from here you can see two information. One is the mean, which is the mu. Another one is the variance, so you just square root it to get the standard deviation. So we can get two information from here. Okay, so how we use it, for example, right, you can see here. So if they write like this, then you have to know that the mean is 15. The standard deviation is without the power 2, which is just 3. Okay, so since we discussed this already, I just write down the mean, which is mu, is 15. The standard deviation, I write short form, sigma, is the one without square, so it's just 3. So from that format, we can find out the mean and the standard deviation, which is very important in normal distribution. Okay, now let's see more information. Number 3, the graph of a normal distribution is bell-shaped. This is the bell-shaped graph, like a mountain, and symmetrical about x equal to mu. So this is x equal to mu, which is the peak of the bell or peak of the mountain, and left and right look symmetry. So that is why they say symmetrical about x equal to mu. The probability is given by the area under the curve. So you want to find probability, you just find area under the curve. So for example, you want to find probability from A to B. So you have to find this area, the shaded area, from A to B. So the shaded area, which is area under the graph, is actually the probability. Okay, so the total area under the curve is 1. Okay, what is the explanation behind this? You know, area under the graph is probability, and you know probability can take a total of 1. So because of that, the total area under the curve, which is the total probability, can only equal to 1, cannot be more than 1. So it's related to probability. So area is probability. So let's say I give you more example. Okay, let's say if you have this as your information, your mean is 15, your standard deviation is 3. So when you want to draw your graph, right, you put fx here, then 15, let's say 15 is here, so 15 is where we have the maximum. So 15 is there. Standard deviation is 3. Standard deviation is somewhere around half of the mountain. The difference is 3 from both sides. It's something like that, standard deviation. So you should be able to imagine that if standard deviation is a big value, like standard deviation is 10, for example, so you should expect the graph to be very fat. Okay, the bell shape should be very fat or widely spread. Okay, of course, it's widely spread. Of course, you should expect the graph to be shorter, as they can only take a total area of 1. So if it's fat, it must be short. If it is thin, the graph is thin, then it should be tall. Okay, so and then after you draw the graph, right? After you draw the graph, so they may ask you to find probability. So how to find probability? Let's say, for example, if they ask you to find px more than 18, then it is area under the graph, 18, and then you find this area, then that area represent the probability. Okay, so now we want to learn how to find the area. Okay, so first of all, we have a problem. The problem is, different kind of normal distribution. For example, let's say like question 1. This question 1, right? We should expect the graph to be like 42 here, and it's wider a bit. 42. Standard deviation is 4, bigger compared to the first graph that I put up there. So fx, x. And then if let's say you want to find probability of x more than 18, again, let's say then 18 is here. Probability of x more than 18 is area in this way. Okay, so what we can see here is different graph seems to end up with different area, because the graph has different shape and the area has different size. Okay, so we have all kind of graph and all kind of area under the graph. That is the problem. So because of that, right, we have number 4 here. Number 4, the standard normal distribution. Okay, so what happened is, because we have different kind of graph with different shapes, and the area is hence different size, so we have a formula to change all kind of graph to a standard normal distribution, which is the same graph. From all kind of graph with different kind of shape, we change it to one type of graph only. The purpose that we change it to this type of graph is so that we can find the area under the graph which represent the probability easily. So that's why we have to change it to this graph. This graph is using Z and FZ. Z and FZ, so we call it standard normal distribution. There is a formula. The formula is given here. You want to change it to Z, right? You take your X minus with mean, divide by standard deviation, then you can change it to Z. When you change it to Z, Z is a normal distribution with mean 0, standard deviation 1. Okay, so mean 0, that means your maximum is at 0. Standard deviation 1, that means the graph you have the same, let's say same shape, no? So halfway of the mountain, to the right 1, and to the left also 1. If you have the same shape, no matter what kind of mean and standard deviation, after you use this formula, then they will change to the same graph. And when we have the same graph, then we can find the probability by using an easier way, which is where we have a table. Okay, we have a table. The table will tell you, the table is a table which is full of numbers, which will tell you different kind of probabilities under this graph. We have one type of graph now. Okay, so you can use a table to find the probability. So we'll come to that later. Now let's finish up the theory here to make it easy to find the area. So you see, we have different kind of graph. Very hard to find area. The area is of different size. So we change it to Z. To change it to Z, we use this formula. Then our graph becomes the same graph. Then we can use this graph to find probability easily, where we use table. What table, I will let you see later. Okay, now let's do some question first. Find the z-score for the given values of x for each normal random variable x. Okay, so you have different kind of, you have the normal distribution in x. So you have to change it to z. So we have to use this formula. Z equal to x minus mu over standard deviation. Okay, so you see how we do it. Z equal to x minus mu over standard deviation. So what is x? It's given 29. What is mean? 25. What is standard deviation? 2. Okay, so you get the z-score. So let's see one more example. Question 5. Z equal to x minus mu over standard deviation. So our x is mu plus sigma. Our mean is mu. Our standard deviation is sigma. So mu minus mu no more already. So sigma over sigma is just 1. So sometimes the z-score look like this. Okay, so it starts from some unknown but end up with a value. So we get the z-score. So remember, we change it to z-score so that we can find probability easily. That is the purpose why we change to z-score. Okay, let's move on. Okay, now you see the notes here. Given x, which is a normal distribution with mean mu, variance sigma square. So and the z-score for x1 and x2 are z1 and z2 respectively. So you can see we have x1, then you use formula to change to z-score, then you get z1 for example. Then you have also x2, you use formula to change it to z-score, then you get z2. Okay? So if you want to find the probability of x less than x1, then you have to change it to z-score by using the formula. The formula that I'm talking about is this formula again. Is the one that we discussed just now. X minus mu over sigma. You see, when it is fx versus x, right, the mean is any value that follow the mean, follow the mu. But if you change it to z-score, the mean is always 0. Okay, then the x value just now, you change it to the z value, then you can use this to find the area under the graph. So the area under the graph will be the probability. So from x less than x1, you change it to pz less than z1. Okay, so
teacher,
yes.
so that x1 equals to z1, the number.
They are not same one. Like for example, just now our question, right, on the previous page, right? Okay, let's take a quick look again. On the previous page, let me check first. The value are different. Let me find out from my book. You see just now our example, x normal distribution 25 2 square, x is 29. So we change it to z, right? 29 minus 25 over 2, z equal to 2. So you can see x and z are different value. X is 29, z is 2, a different value. Okay, so they are different value. You see, like here also, x1 seems to be a positive value. After you use this formula, change it to z1, z1 seems to be a negative value now. You see, it's on the left hand side of 0, so it seems to be a negative value. So they are different. You just need to use this formula. Whatever you get, that is your z1. Okay, so what are they trying to show in this note is, you want to find this probability, you cannot find straight away one. You have to change it to z by using this formula. Then only you use the z graph to find the area under the graph that represent probability. So why we need to change it to z? Because mathematician has list down the area under the graph for this graph. Not this. Okay, they don't have time to find out the area under all kind of fx versus x graph. Too many type of graph, so that they only work out the area of the standard graph in a table. So you see a table which is full of values, which represent area under graph of this graph, the z graph. Okay, so that means the main idea is, you want to find probability, you change it to z, and then you use a table to check the area under the graph, then you will get the probability. Okay. Now they try to give another example. If you want to find the probability of x in between x1 and x2, so which is this kind of shaded region between x1 and x2, so what happens is, you have to use this formula to change it to z1 and z2. z1 is here, z2 is there, then you are finding area in between z1 and z2 by using the table that I mentioned just now. How we use, we'll discuss in detail. So once you get the area under the graph, that is the probability. Okay, so the probability of z1 to z2, which is at the same time the probability of x1 to x2. So we change it to Z to find probability. So finally, you see the third graph. If you want to look for the probability of x more than x2, right? So the shaded area is on the right because it's more than. So again, you use this formula, change it to Z2. You change it to Z2, then you have to find the area on the right of Z2 by using the table. That table will tell you the area under the graph, and you get the probability because area under the graph is probability. So you get the probability of this, then this one will be taking the same value for the probability. So you can see here, the probabilities for Z can be found from the standard normal distribution table. So the table that I mentioned just now is a standard normal distribution table. Or you can also use calculator to find out the area under the graph, which is the probability. So we will see everything in details. So let's look at part C. Find the probability of each of the following normal distribution. Okay, so let's see. Okay, part A, we have x, which is a normal distribution. Mean is 20. Standard deviation is 2. Okay, now the question is missing. The question is, find the probability of x less than 19. Less than 19. So they want us to find this probability. So you see, it's belonging to this situation, x less than something. So you need to change the x1 to z score by using this formula. By using this formula to change it to z1. Okay, you see how we do it. The x we change to z. The 19 we use formula to change it to z1. 19 minus mean divided by standard deviation. Now remember, this is sigma square. Sigma square is 4. So sigma is 2. Is 2. Okay, so z less than negative 1/2, negative 0.5. Okay, so we get this. Okay, now when you get pz less than negative 0.5, so we want to find the probability, we supposed to use the standard normal distribution table or calculator. Okay, let's say we use calculator first. Okay, so we use calculator first. You get ready with your calculator. So I will just press together with you, and I will tell you which button to press. Okay, so first of all, you have to press stat. Okay, stat. You press stat, and then after that you choose distribution. After that, you will see PQR. Okay, so you have to choose P. You have to choose P. Okay, this is how we press calculator. Why we choose P? P is for less than or equal. Less than or equal, you choose P. So our question is less than or equal for this case here. As you can see, this is less than. We use P. Okay, so after the P come out, right, you just need to do like this. In your calculator, after the P come out, you put the negative 0.5 inside. Then you press equal. Then the calculator will count out the area under the graph, and you will get 0.30854. Okay, you will get this value, 0.30854. That is the yes.
Calculator is not the same as yours.
Oh, okay. So then can you let me know what calculator you are using?
The class Swiss one.
Okay, so hold on. Okay, so what you say is you are using class V's. Okay, now let's see, which means for cashier FX570EZ, sorry, EX, class V's, how to press. Okay, so let's take a look for this calculator. Okay, first you press menu. After that, you see number 7. Number 7 is basically the normal distribution, and you see the graph, which is like this one. Okay, so you choose 7. Okay, so after you choose 7, right, then we see normal. We see normal PD and normal CD. Okay, so after you press menu 7, then what to do is you press number 2, which is normal CD, number 2, normal CD. Normal CD means normal cumulative distribution, and then you will see lower, upper, sigma and mu. So you see all this. Of course mu is temporarily hidden, so you will be able to see afterward. Okay, so I tell you what to press for each of these. Okay, I will draw the graph at the same time so that you understand the graph together with how you press calculator. You know, when you change it to Z, right, so the graph is always having the maximum in the vertical axis, which is the FZ axis. The graph is having maximum there. Okay, now our Z value is negative 0.5. Okay, negative 0.5, so which is somewhere around here, negative 0.5. 0 is in the middle, and then we are looking for the probability which is less than negative 0.5. So less than negative 0.5 is here, all the way to the left. Okay, so when the calculator asks for lower, right, so you just put any value which is very very negative, any, try to be as big as possible. Let's say, for example, let's say I key in negative 10,000. Okay, so why negative 10,000? Because I want to key in a value which is on the left. Then the upper, right, so if you want to key in negative 1 million, just go ahead, so you get the same answer at the end. Okay, so for the upper is this value, because our shaded region is from a very negative value to negative 0.5. Negative 0.5 is the upper boundary, negative 0.5. Okay, our standard deviation is what? Remember, we already changed it to z-score. Our z-score, right, the normal distribution, right, is always having mean 0 and standard deviation 1. So for the standard deviation, you put 1. For the mean, you put 0. Okay, so then you press equal, then that will show us the probability 0.30854. Okay, if you go and round off a little bit. So that is how we press the calculator. Do you get this value?
Yes.
Okay, so I will keep using calculator for temporarily to discuss with you on how to press calculator for all this. Okay, so of course we need to know how to use table also. So the table I will discuss with you later. Okay, so maybe in the next lesson. Okay, now let's look at B first. Okay, look at B. So you have this normal distribution. Okay, and then the question is missing. The question want us to find, I add back the question, px more than or equal to 47. 47. Okay, so first you have to change it to z-score. The x you change to z straight away. Inequality remain. The number you use formula to change. So the formula is x minus mean over standard deviation. Okay, again, the 9 is sigma square. So the sigma, which is standard deviation, is hence 3. So we have 2 over 3. 2 over 3. So more than or equal to 2 over 3. Okay. So of course, if you are using calculator which is not class B's, you have to press Q. Same thing. Sorry, not Q. R. You have to use R. There are PQR. I have to use R. But for class V's, so how to press? Okay. So once you reach here, you just press menu 7 2, and then you have lower upper again. Okay. So you just press all that first. Okay. Now we have to change the lower and the upper. Okay. What is the lower and what is the upper? You see the graph. Okay, imagine for this round, fz versus z. 2 over 0 is in the middle. 2 over 3 is just somewhere on the right of 0. More than or equal to 2 over 3 is the shaded region on the right. So because of that, right, when you press lower, right, you see our shaded region, the left hand side is 2 over 3. So you just press 2 over 3. 2 over 3, you change to 2 over 3. The upper, right, you see our shaded region is going all the way to the right. So you just take any big positive value. For example, let's say 10,000 or 1 million. It's up to you. Okay, let's say I put 1 million. Okay, so then standard deviation is 1 million. 1 million. Standard deviation is 1, mean is 0. Okay, so after that, you press equal, and you're supposed to get 0.25249. Okay, so you will get that. So the calculator will show P equal to 0.25249. But when you write, you just write like this. Just write like this. Okay, so of course, if you are using the previous type of calculator, you have to choose R. So then you add here R 2 over 3. You have to add here R 2 over 3. If you are using the old calculator, R 2 over 3, and then only put the answer. Okay, now let's see one more example. Okay, one more example. Okay, part C. They give us the mean and standard deviation. So now the probability is missing. They ask this 60 to 65. They ask this. So they want us to find probability from 60 to 65. So again, we change it to z-score so that we can use calculator. For number, we always use this formula. We always use this formula to change it to z-score. 60 and 65, you have to use this formula. For x, you just change to z straight away. Okay, so that means something like this. the middle one we change to z straight away, but for the two values, the 60 and the 65, we do like 60 minus the mean over the standard deviation. Okay, imagine this is sigma square is 5, standard deviation is square roots of 5, so over square roots of 5, 65 change to z score minus mean 63 over square roots of 5. Okay, now we change it to decimal first. Negative 3 over cert 5. Okay, let's say I change it to decimal, negative 1.3416. 65 minus 63 divided by square roots of 5. So I change it to 0.8944443. Okay, now to press calculator, so of course again menu 7 number 2, so menu 7 number 2, choose normal CD. So the lower is this value, so which is negative 1.3416, negative 1.3416. The upper is this value, 0.89443. Standard deviation 1, mean is 0, and then you will get the probability, which is 0.7246. So like that. Okay, we see the graph also, just to understand more on the graph. Not compulsory to draw out the graph in exam. So the graph is always the same shape. Once you change it to z, the graph is always having maximum at 0. Negative 1.3416 is on the left of 0, somewhere over there. 0.89443 is somewhere on the right. So the shaded region is in between. So that's why this become the lower, this become the upper. Okay, so you try to look at the graph at the same time to get the idea.